Okay, so for GP number 1, we are looking to break each of these numbers down into their prime factorizations. So if you refer back to the vocab, we said prime factorization is where you break a number down into its prime factors. Now, the easiest way for this to be done is to divide out the smallest prime number as many times as possible, and then you move on to the next smallest prime number. Now, the method that I'm going to show you is what I refer to as the cake method. This is nothing technical. This is just a method that I use for prime factorization, as well as simplifying radicals that we'll see later in the year. And so what you're going to do is you're going to take the number, so for the first one is 96, and you're going to put it inside of a box like this. And as I stated, you're going to divide out the smallest prime number as many times as possible. So just to reiterate, our prime numbers are 2, 3, 5, 7, 11, etc. So we're going to start always by dividing out 2 as many times as possible. So I'm going to start by dividing 96 by 2. So 96 divided by 2 gives us 48. Then I'm going to divide 48 again by 2, if possible. 48 divided by 2 gives us 24. Can I divide 24 by 2? It's still an even number, so I can still divide it by 2. So 24 divided by 2 gives us 12. Still divided by 2 if possible. 12 is divisible by 2. 12 divided by 2 is 6. 6 divided by 2 is 3. 3 is not divisible by 2, so I move to the next smallest prime number, which is 3. So 3 divided by 3 is equal to 1. And so that is when our prime factorization is done. So the prime factorization for the number 96 is 2 times 2 times 2 times 2 times 2 times 3. And if you multiplied that all back out, it would be equal to 96. And again, this is the prime factorization because this is the product of all of its prime numbers. So now we're going to do the same thing for 108. We're going to start by dividing out the smallest prime number, which is 2. So again, remember that in order for us to determine whether or not a number is divisible by 2, we look at the last number. If it's an even number, then it is divisible by 2. So 108 divided by 2 is 54. 4 is even, so I can still divide by 2. 54 divided by 2 is 27. Now, 7 is not an even number, therefore 27 is not divisible by 2. So we have to move on to the next smallest prime number, which is 3. 27 divided by 3 is 9. 9 divided by 3 is 3. And 3 divided by 3 is 1. So again, we get down to 1. Our prime factorization is complete. And the prime factorization of the number 108 is 2 times 2 times 3 times 3 times 3. Now, I use this method also to help me find the greatest common factor of two numbers if it's not completely obvious. Now, if we had, say, the numbers 4 and we'll say 6, we know that the greatest common factor of these two numbers is the number 2. That is the biggest number that divides evenly into both of these numbers. Now, when you get to numbers like 96 and 108, it's not as obvious what the greatest common factor is. And so it's really simple for us to quickly break down our numbers using prime factorization, and then we can kind of put it back together to figure out what the greatest common factor is. So using prime factorization to find the greatest common factor, you're going to look back at the prime factors and see which numbers they have in common. So these two numbers have a 2 in common. So that's going to be the first number in my GCF. They also have a second 2 in common. So I'm going to put that with my GCF. And when we put it back together, we're multiplying. So this has 3 more 2's, but the 108 does not have any more 2's, so we can't use more than 2 2's. So we have a 3 over here, and we also have a 3 over here, so that will also be included in my GCF. Now, because there are no more 3's for 96, we're done. The prime numbers that they have in common are 2 2's and 1 3. So to figure out the greatest common factor, we multiply those numbers together. 2 times 2 is 4, and 4 times 3 is 12. And that is the greatest common factor of 96 and 108. And again, this process right here is referred to as prime factorization. Make sure you guys have stuff in your toolbox. All right, so for GP number 2, what we're looking to do is to rewrite each polynomial in factored form. So what we have to do is figure out the greatest common factor of the two terms in the polynomial, and then we have to factor that out and write it in factored form. Now, if you refer back to the Explore, factoring is essentially the opposite of distributing. So what we're looking to do here is figure out the number that would have been distributed to give us this polynomial here. So again, we have to figure out the GCF of 2x and 4. So we're going to start by looking at the numbers, and 2 and 4 are both divisible by 2. So the greatest common factor of this polynomial will begin with the number 2. And again, if you get stuck and you can't really figure out what the what the greatest common factor is of the two numerical values, that's when you can use the cake method, break it down to its prime factorization, and see what prime factors they have in common. So if you ever get stuck, that's kind of the default method to helping you figure that out. Now with the variables, notice that the 4 does not contain an x, and you're only going to include a variable in your GCF if all of the terms in your polynomial contain a variable. So in this case, our greatest common factor does not include a 2. It does not include an x, it's just going to be the number 2. So what we're going to do is we're going to factor that 2 out of our polynomial. So when you factor, again, we're undistributing, and distributing is multiplying, therefore factoring is division. So we're going to divide each of our terms by the number 2. And when we write it in factored form, we must always write the GCF out in front of the parentheses. So if we divide out the 2 from this polynomial here, 2 divided by 2 is equal to 1. So 1x will go back inside the parentheses, plus 4 divided by 2 is equal to 2. And this is our factored form. Now this 2 is the GCF of the polynomial, and that GCF will always get written out in front of the parentheses, and the parentheses, or what's in the parentheses, is what's left over when you divide out the GCF. And again, this is your factored form. All right, so let's take a look at another one. So first step, make sure you're writing your toolbox. First step is to find the GCF of the polynomial. So for our numerical values, we have 12, 30, and 6. So we want to figure out the greatest common factor between 12, 30, and 6. Now, again, if you get stuck and you're not really sure, the best thing to do is to cake your numbers and figure it out. But for this one here, the greatest number that all three of these numbers are divisible by is the number 6. Then we want to check for variables. We have x squared here, we have x here, but we do not have an x on the 6. So our greatest common factor will not include an x. So our greatest common factor is the number 6, and now we're going to factor that out. So we're going to divide each term by 6. So the 6 goes out in front of our parentheses. 12 divided by 6 is equal to 2, and we still have that x squared there. Negative 30 divided by 6 is negative 5, and that x is still there. And 6 divided by 6 is 1, and that's a positive, so plus 1. Now you have to make sure that any time your GCF is one of the terms of your polynomial that you include that 1. Now, if there's a variable, we don't have to write 1x or 1x squared, but if it happens to be the constant, you do have to put that number there, because if you were to redistribute this 6 to check your answer, you should get the same polynomial that you had to start with. And if there's no term here at the end, then you're not going to have anything to multiply the 6 to, which is not going to give you the 6 in the original polynomial. So again, you must always put the 1 when you divide out if there's nothing else left over. And again, this is the factored form when you divide out the greatest common factor. All right, let's take a look at another one. So for this one here, notice these numbers are getting a little bit bigger. So I'm going to show you here how we would apply the cake method to figuring out our greatest common factor. So again, I'm going to take 24 and I'm going to break it down into its prime factorization. So again, my smallest prime numbers are 2, 3, 5, 7, etc. So it's 24 divisible by 2. It's even, so it is divisible by 2. 24 divided by 2 is 12. 12 is also divisible by 2. 12 divided by 2 is 6. 6 divided by 2 is 3. 3 is not divisible by 2, but 3 is divisible by 3, and it equals 1. Then we need to do the same thing for 72. The smallest prime number that 72 is divisible by is also 2, because 72 is even. So 72 divided by 2 is 36. Still even, so 36 divided by 2 is 18. Still divisible by 2. 18 divided by 2 is 9. Now 9 is odd, therefore it's not divisible by 2, so I move to 3, and 9 is divisible by 3. 9 divided by 3 is 3, and 3 divided by 3 is 1. So then we want to check to see which numbers they have in common. So we have a 2 in common. We have another 2 in common. We have another 2 in common. And then we also have a 3 in common. So our GCF is going to be 2 times 2 times 2 times 3. So 2 times 2 is 4. 4 times 2 is 8. And 8 times 3 is 24. So this 24 happens to be the greatest common factor of 24 and 72, because both of those numbers are divisible by 24. So now we're going to rewrite our polynomial in factored form. So we have to, oh, I'm sorry, I missed the variable. So notice that both of our terms do contain a variable. So this one is x to the third power, and this one is x to the second power. Now, if I were to break these variables down, similar to this prime factorization, x to the third power would be x times x times x, and x to the second power would be x times x. So they have one x in common. They have two x's in common. So kind of as a rule of thumb for your GCF, the variable that they have in common is always going to be the variable with the smallest exponent. So in this case, the x squared is the smallest exponent, therefore the x squared will be part of your greatest common factor. Whereas in part A and B, there was no variable on that last term, therefore there is no variable in the GCF. So the greatest common factor is going to be 24x squared, and that's the value that we're going to factor out of our polynomial. So let me go ahead and rewrite our original polynomial. We have 24x cubed minus 72 x squared. So I'm going to divide out the greatest common factor, which is 24x squared. So I'm going to divide each term by 24x squared. So I rewrite the 24x squared out in front of my parentheses because the GCF always has to appear in our final answer. Now 24 divided by 24 is equal to 1, but we still have a variable left, so we don't have to write the 1. Now with the division of your variables, I'm going to kind of break this down for you. If you have x to the third power in the numerator, that's x times x times x. And if you have x squared in the denominator, that's x times x. So what happens here is you divide out however many x's they have in common. So x divided by x is 1, x divided by x is 1, and we're left with 1x, or x to the first, in the numerator. So what happens is essentially you're just subtracting your exponents. So if you have 2 in the denominator and 3 in the numerator, 3 minus 2 is 1, you're going to have that 1 left in the numerator. So you're going to have 24 divided by 24, which is 1, and then x left. So this is just going to be x. And again, if you think about it, when you redistribute, we would add the exponents. So that would give us 24x to the third. 72 divided by 24 is 3. And you have x squared divided by x squared. Well, 2 minus 2 is 0. So you would have 0 x's left. Well, again, let me just expand that and show you. You have x times x divided by x times x. These divide equal 1. These divide equal 1. So you're left with just 1. You are not left with x. It's a very common misconception, so please be careful. So x squared divided by x squared is equal to 1, but we already have this 3 left over. So our factored form is 24x squared times x minus 3. And again, remember to check your work, you could redistribute that greatest common factor back into your parentheses to see if you get the original polynomial. All right, let's look at one more and then we'll be done. All right, so I want to do cake again just to show you guys some practice with that. So we're going to cake 60. Our smallest prime number is 2. 60 divided by 2 is 30. 30 divided by 2 is 15. Now 15 is an odd number, therefore it's not divisible by 2, but it is divisible by 3. 15 divided by 3 is 5. 5 is not divisible by 3, and so our next prime number is the number 5, and 5 divided by 5 is 1. So the prime factorization of the number 60 is 2 times 2 times 3 times 5. All right, for 15, smallest prime number is 2, but 15 is odd, so it is not divisible by 2. Next smallest prime number is 3. 15 divided by 3 is 5. 5 is not divisible by 3, but 5 is divisible by 5, and 5 divided by 5 is 1. So the prime factorization of 15 is simply 3 times 5. All right, for 75, 75 is not divisible by 2 because it is not an even number. The next smallest prime number is 3. Now, I want you guys to be careful here because a lot of students have the tendency to want to just divide by 5 right here because they see that it ends in a 5, therefore it's divisible by 5. However, moving forward, when we start using the cake method to simplify radicals, we always want to take out the smallest prime number first. And 75 is divisible by 3, so we want to start with that 3. Now, one of the tricks to figuring out if a number is divisible by 3 is to add your digits together. So 7 plus 5. 7 plus 5 is 12. If the number that you get when you add your digits together is divisible by 3, then your original number is divisible by 3. So 7 plus 5 is 12. 12 is divisible by 3, therefore 75 is divisible by 3. So go ahead and test me. 15. 5 plus 1 is 6. 6 is divisible by 3, therefore 15 is divisible by 3. The number 60. 6 plus 0 is 6. 6 is divisible by 3, therefore 60 is divisible by 3. Okay, and that will work for any number to check to see if it's divisible by 3. So 75 divided by 3 is 25. So now we can add these together to see, is 5 plus 2 a number that's divisible by 3? Well, 5 plus 2 is 7. 7 is not divisible by 3, therefore 25 is not divisible by 3. So we have to move on to the next smallest prime number, which is 5. 25 is divisible by 5. It is 5 times 5. 5 divided by 5 is 1. So the prime factorization of 75 is 3 times 5 times 5. So let's go ahead and put this back together to figure out the greatest common factor. So here we have a 2, but these two values are not divisible by 2, so the 2 will not appear as part of our greatest common factor. So we move on to the next one, and this has a 3. They all three have a 3 in common, so the GCF will start with a 3. They all have a 5 in common, so 3 times 5 gives us 15, and that is the numerical part of our greatest common factor. So let's check our variable. Do all three terms have a variable? Yes, they do. And again, the variable that you will include in your greatest common factor is the variable with the smallest exponent. So there are 3 x's here, there are 2 x's here, and there is 1 x here. So therefore, they all have 1 x in common. So the greatest common factor is 15x. So let's go ahead and factor that number out. Let me rewrite this. So we have 60x cubed plus 15x squared minus 75x. And we are going to divide out, factor out 15x. So 15x must go out in front of our parentheses. The GCF must always appear in our final answer when we are factoring. So 15x, let's see what we get when we divide. 60 divided by 15 gives us 4. X cubed divided by x. Now remember, there's an invisible exponent here. So we have to subtract our exponents, and 3 minus 1 gives us 2. So that gives us x squared. Plus 15 divided by 15 is 1. X squared divided by x to the first is going to leave us with x to the first, because 2 minus 1 is 1. So we have 1x to the first, but remember, we don't write a 1 in front and we don't write a 1 as an exponent. That's implied. Minus 75 divided by 15 is 5, and x divided by x is 1. So we have, it's 1, but it's 0 x's. So we have no x's left when we divide those out. So we have 4x squared plus x minus 5, and that is our factored form. Make sure you guys answer your essential question at the end of your notes.